Hi, my name is Mr. Chun. You're welcome to my study room. If today is your first time, then I encourage you to subscribe to this channel for more videos. For some weeks now, we have been on circle theorems, and this study is going to be the last one on the theorem for now, so that maybe later we can add some questions. So, ending it, I've decided to solve a number of questions just to enhance your application of the various theorems that we've done so far. And before you go ahead with these questions, I want to encourage you to go back and watch the videos on the various theorems so that you can catch up with what you are doing, because if you've not yet watched, or if you don't know the theorems, you will not understand the way the questions have been explained. So I encourage you to revise the theorems and know them very well. And just as closing remarks for this topic, I want to state clearly that the number of the theorem doesn't matter, whether it is theorem 1, 2, 3, or 4, but what the theorem says and the hints for you to know which theorem to use for which question is the most important thing. For example, if the question gives you the center of a circle, it means that you should be exploring any of the theorem which talks about a line passing through the center of the circle, or a chord subtending an angle at the center of a circle, or something. If the question talks about a line being a tangent to a circle, it means the question is expecting you to apply the theorems that talks about the tangent to a circle and the relationship between that and the angles, and so on and so forth. Those are the most important things you need to remember. Your ability to identify or notice which of the theorems to use when you see a question. So that is what this one is going to be about. Let's go and solve the questions and talk later after the lesson. Thank you. Our next question is WASSCE 2020, the essay questions, or the written part, question 3A, and it reads: in the diagram, I, J, K, L are points on a circle such that angle JIL equals 3y and angle KML equals 2y. If angle KLM equals 55 degrees, find the value of y. Alright, so here we can see that this is a circle containing a cyclic quadrilateral IJKL. One side has been extended, or the quadrilateral, yes, one side has been extended to a common point M with an angle 2y created there. Let me quickly state that these are not tangents, because the tangent is not supposed to cut through the circle. It's just supposed to touch the circle. So these are not tangents. This is just this side that has been produced or extended to a point, or two vertices J and two vertices L and K extended to meet at M. Alright, how do we go through this question? Very easy. Looking at this question, this angle 3y here is the same as the angle here, LKM. So let me just write that quickly and come and explain. Yeah, angle LKM equals angle JIL equals 3y. And this is the reason why. This is a cyclic quadrilateral, and this plus this should give us 180 degrees. Is that not so? Yeah, that is true. And then this is also JM is also a straight line, and the sum of angles on a straight line is 180 degrees. So if this plus this should give us 180, and this plus this should also give us 180, then the only way it can be true in both cases is when here is also 3y. Because if here is 3y, then whatever we get here, when we add, it will give us 180. And because here is also 3y, whatever we get, when we add, it will give us 180. So that is why here and here are equal. So the common difference is just here. All right. When we get that, then now we take triangle LKM and the sum for which we should get 180 degrees. And that is just what we are going to do. So taking triangle LKM plus angle KML plus angle KLM should give us 180 degrees, which is the sum of interior angles of a triangle. So now we know LKM as 3y plus KML as 2y, then plus KLM at 55 degrees, and that should give us 180. Let me just cancel the degree sign for now. So adding all, we are going to have 5y plus 55 equals 180. 5y will be equal to 180 minus 55. 5y will give us 125. Dividing both sides by 5, we are going to have our y to be 25 degrees, and that is our answer. Very easy. The next question is question 11A of the same paper, WASSCE 2020, and it reads: the diagram shows a circle center O with C and D as points on the circumference. Line segment DQ is a tangent produced at Q. Find the value of M. Alright, so with this question again, there are a number of the theorems we are going to identify here. We will need to apply any of the theorem that talks about the center of the circle, and any of them that talk about the tangent, because these are the main points that are stated. So first of all, applying the center, we can see that triangle COD is an isosceles triangle because this is the center of the circle and this is the radius of the circle. OC is a radius and OD is also a radius. So if they are radius, then the two base angles are the same. So that means that here being 25 degrees, here will also be 25 degrees. And then angle COD will be 180 minus the 50 for the 2, which will give us 130 degrees. So that means we will need this angle to be able to calculate for our M, DOQ, to calculate for our M. That means the DOQ is 50 degrees, because if this is 130, then here will be 50, because angles on a straight line sum up to 180 degrees, or that property of triangle we've used for a number of times now. This is an exterior angle. So if this is an exterior angle, then the sum of the two opposite interior angles should be equal to the exterior. So if this is an isosceles triangle and these are 25 each, then here will be equal to the 50 degrees you are looking for. So let's write that quickly. Triangle, let's start with triangle COD. Triangle COD is isosceles. So this implies that, let me keep it on the diagram while I write. So this implies that angle OCD will be equal to angle CDO, which will also be equal to 25 degrees. So with the explanation I've given, we can also write that angle QOD will be equal to angle OCD plus angle CDO, which will give us 50 degrees. Yeah, I intentionally kept the camera on the diagram so that I can be reading what I'm writing out and then you look on the diagram and relate. Alright, now that we know angle QOD as 50 degrees, we know here too from the theorem that involves the tangent, because this OD is through the center of the circle and this is a tangent, so that means that this angle, do you remember? Yes, 90 degrees. So let's write that quickly. Angle ODQ is 90 degrees. Alright, then now we can take triangle QOD. Taking triangle QOD, angle QOD plus ODQ plus DQO should give us 180 degrees. So let me write that quickly. Taking triangle QOD, angle QOD plus angle ODQ plus angle DQO should give us 180 degrees, because that is sum of interior angles of a triangle. Now we've established that angle QOD is 50 degrees plus is also 90 degrees plus DQO is M. That should give us 180 degrees. Good. Now let's come to this now. That means 140 plus M should give us 180, and our M equals 180 minus 140. Therefore, our M will be equal to 40 degrees. So that is just the answer to our question. Simple as that for this question. Let's go on to the next question. The next question is question 12A of the same paper, WASSCE 2020, question 12A. And it reads, in the diagram, O is the center of the circle ABC, and angle BCA is 41 degrees. Find I, angle BOA. Angle BAO. So these are the angles we are looking for. Angle BOA, which is here, and then the second one, BAO. Good. Now the question gives us some hints, and these hints given are what you are going to look out for, and they must be related to the theorems we've learned earlier so that we can solve the question with them. And I think here the only hint given is that O is the center of the circle. So with the center of the circle, the very theorem that comes straight to mind is the one which involves the use of a diameter, because this is the center of the circle and CD is the diameter of the circle, because the diameter is a chord which passes through the center of the circle. So if CD is the diameter of the circle, then it means that, do you remember that theorem? It means that CAB is 90 degrees. And the angle CHB is 90 degrees. But remember, they didn't tell us that this triangle CAB is isosceles. So you don't assume that this OA passing here divides the 90, which is CAB, into two equal parts. No, you cannot conclude that way, because they didn't tell us that this triangle is isosceles. And it is not enough to just look at it and think it is isosceles. No. But then there is another thing we can see, which is that triangle CAO is an isosceles triangle, and the triangle AOB is also isosceles. Someone might ask that, but this one too, they didn't tell us. Yes, they didn't tell us, but we know that the length OC is a radius to the circle, and then OA is also a radius, and OB is also a radius. So it means that this side and this side are equal, and this side and this side are equal for the two separate triangles. So that idea will be employed here. So if they are equal, it means that this angle here is also going to be 41 degrees. Is that not so? Because they are the base angles of this isosceles triangle AOC. You see? So let me just write that quickly. Let me just say triangle AOC is isosceles. And that implies that angle OCA will be equal to angle CAO, which will also be equal to 41 degrees. Alright, so now that we know here and we know here, we can find here now. And that is what will lead us to find our angle BOA, which is the first question we are looking for. So, taking the same triangle AOC, we know that angle BCA, which I will now call OCA, angle OCA, which is this one, plus angle CAO plus angle AOC, this AOC, will give us 180 degrees. That's the sum of interior angles of triangle AOC. So we know that OCA is 41, CAO is also 41, plus angle AOC should give us 180 degrees. So angle AOC will give us 180 minus, this is 82, and that will give us 98 degrees. Therefore, angle AOC equal 98 degrees. That 98 degrees is just here. And remember, that is not what we are looking for. We are looking for BOA. But BOA is on the same straight line with AOC. So angles on the straight line. So we are going to write angle AOC plus angle BOA equals 180 degrees. And I explained that it's because they are on a straight line, angles on a straight line. And now we know our AOC to be 98 degrees plus angle BOA, which we are looking for, to give us 180 degrees. So angle BOA is going to be 180 minus 98, and this will give us 82 degrees. Therefore, angle BOA equals 82 degrees. So this is a way of solving. But then, as we have explained in earlier examples, instead of doing this long thing, you can also conclude that this is an exterior angle of the triangle AOC. Therefore, the sum of the two interior angle 41 plus 41 will give us the opposite exterior angle, which is 82. And then that just simplifies it. Let's go to question 2. The second question, II. So II is asking us to find angle BAO. That is the angle at A using this second triangle. And BAO, do you remember the theorem as we said at the beginning, that because this is a diameter, this one subtends an angle of 90 degrees here. So it means that angle CAO plus BAO should give us 90 degrees. So let me just write that. We know CAO from the first calculation, that is 41 degrees, plus angle BAO should give us 90. So angle BAO will be equal to 90 minus 41. And that will give us 49 degrees. So therefore, angle BAO equals 49 degrees. Let's go on to the next question. The next question is question 12A of WASSCE 2019, and it reads: the diagram shows a circle ABCD with center E. Quadrilateral EADC is a rhombus. Angle BAE equals angle ECB equals N, and angle ABC equals M. Find question IM and question IIN. Looking at this question, you see that it has no angle given at all. So we have to apply the theorems we have learned already to see if we can make any meaning out of it. The key things we have to note here are that first one, we were given the center of the circle, so we have to check and see if we can use any of the theorems that applies the center of the circle. And yes, we can get the theorem in which a chord subtends an angle at the center and the same chord subtends an angle at the circumference again. We can use that, and then we can also identify the theorem that involves a cyclic quadrilateral, because when we assume we take off this side, we can see that ABCD is a cyclic quadrilateral, and then we were also told that AECD is a rhombus. So we have to apply the properties of a rhombus. Then we can go ahead and solve. Applying the theorem which talks about a chord subtending an angle at the center and the same chord subtending at the circumference, we can conclude that if here is M, then here will be 2M. Let's come back to our diagram. We can also apply the one which involves the cyclic quadrilateral, the theorem which involves the cyclic quadrilateral. And that one says that angle ABC plus angle ADC should give us 180 degrees. So it means that angle ADC is going to be 180 degrees minus M. So let's write that. Good. Then let's come back to the rhombus EADC. One of the properties of a rhombus is that the opposite angles are equal. So it means that this angle AEC and ADC are equal, or AEC is equal to ADC, and also EAD is equal to ECD. That's one of the properties of a rhombus. So I think since we know here but not the full value, and then we know here too, we can equate the two of them to help us find the value of M. Let's now substitute the values and work it out. Let's group like terms. Yes. So from that, it means that the value of our m is 60 degrees. And that is our answer. We go and see if we can now find the value of our n. Let me just make here Roman number 1. So question I. Let's go and find the value for our n now. There are two ways we can find the value of n actually. And I think the easiest way is to consider the diagram ABCE as a quadrilateral, and then we use that to solve our question. Because if we take that one as a quadrilateral, then the reflex angle AEC is just going to be 360 degrees minus the 120 that we have here, and that will give us 240 degrees. And after that, we know that the sum of interior angles of a quadrilateral is 360 degrees, and we know the value of m. So with that, we just find our answer quickly. So let's go and do that, taking quadrilateral ABCE. BCE is n, and CEA is 360 minus m. Okay, so this is no part. All right, then now we simplify further. All right, so let me take my time and then explain each of them slowly. So looking at the diagram, angle BAE is n, angle ABC is m, angle BCE is n, and then angle CEA is 360 degrees minus 2m, because this is 2m plus the reflex angle will give us 360 degrees. So if this is 2m, we just take 2m from 360 to get this. That's all we got that. And then we went ahead to simplify by grouping like terms. So m plus n will give us 2m. Then when we open this parenthesis, m minus 2m will give us negative m. Then our 360 is here, all equals to 360. Then 2n minus m will give us, this is positive, so when you can, the 360 minus 360 is 0. And then now we substitute the value of m, which is 60, that we found here already, into it, and then we make n the subject to get 30. That to me is the easiest way to solve it. But then there is another way of solving where we consider the bigger triangle ABC instead of considering the quadrilateral ABCE, because in fact not many people will see this diagram here as a quadrilateral, so it is easier to see it as a triangle too. Because of that, let's just use that one as an alternative method of solving. So alternatively, we say triangle AEC is an isosceles triangle. That means angle EAC equals angle ECA. Since we know angle AEC already, which is 2M, we can use that to find these two angles that are written here. So let's write that too. Sum of interior angles of a triangle. Since EAC equals ACE, we can just choose one and say twice of that. So twice angle EAC plus 2M will give us 180 degrees. So twice angle EAC plus 2 M is 60 equals 180 degrees. So twice angle EAC will be equal to 180 degrees minus 120 degrees. So twice angle EAC should be equal to 60. Divide both sides by the 2 angle EAC will be equal to 30 degrees. It means that here is 30, here is also 30, and then when we add, which will give us 60. So when we add the 120 here, it will give us 180 degrees, which is the sum of interior angles of a triangle. Then after that, now that we know here as 30, here too as 30, we are now going to take the bigger triangle ABC now. Taking triangle ABC, angle BAC plus angle ACB plus angle ABC equals 180 degrees. And from the diagram, BAC is N plus the 30 degrees we found, and then ACB is also N plus the 30 we found, and then this is M. So let's go and fix that. So BAC is N plus 30 plus ACB is also N plus 30. ABC is M. Should be equal to 180 degrees. So when we simplify further, we are going to get 2N plus 60 plus our M is also 60, and that should give us 180 degrees. To simplify further, 2N would be equal to 180 degrees minus this by this is 120, so 120 degrees. And then 2N will be equal to 60. And when you divide both sides by 2, our N will be equal to 30 degrees, which is the same as the 30 degrees we found here. So the two approaches depends on which one you are more comfortable with, or which of them you are able to identify on the day of the exam, as to whether you should consider this as a quadrilateral, which I think is the easiest way though, or you consider the bigger triangle ABC, where you find the internal ones, then you go and find the external ones. So it's about which of them you want or you are more comfortable with. Let's take the next question. And the next three questions are objective questions. So I will crave your indulgence for me to just explain without necessarily writing, since we have done so much of the writing already. And I should add that this one shouldn't prevent you from pausing and writing them one by one if that is what will make you understand. You can just pause this video and then you'll be writing them one by one to explain to yourself. So I am just going to explain now without writing all the points. Then we select the answer from the alternatives given. So this is the question 38 and 39 actually of WASSCE 2019, the objective questions. So the diagram answers 38 and 39 is there. In the diagram, PX, line segment PX and line segment RS are tangents to the circle with center O. Angle PSR is 70 degrees. Angle POR is M and angle PQR is N. Use this information to answer questions 38 and 39. And like I said earlier, these are questions 38 and 39 of WASSCE 2019. So let's go to question 38. It says find the value of M. This is M. We are going to find M. So what do we do? First of all, these are tangents to the circle, PS and RS. And since they are tangents to the circle and the circle has the center O, you know what that means. It means that this angle here is 90 degrees. This angle here is also 90 degrees. So if they are 90, OPSR is a quadrilateral, and the sum of interior angles of a quadrilateral is 360. So it means that when we add 90 plus 90 plus 70 plus M, we should get 360 degrees. And that only means that when we subtract 1, 2, 3 from 360, we should get our M. So that's what we are going to do. So let me just do that quickly. So you're going to have 90 plus 70 plus 90 again will give us 250. So plus our M should give us 360. So since we are making M the sum, 360 will be, M will be 360 minus our answer. So 360 minus answer, and that is 110 degrees. So that is the answer for our M. It means that we need to put 110 degrees here, and then when we add all four, we are going to get 360. So looking at the possible answers, our answer is going to be option B, which is 110 degrees. Then we check question 39. Question 39 is asking us to find the value of N. So let's go back to the diagram. Very easy, very easy. So if we connect R and P, or P and R as a chord, then you remember that first theorem where a chord subtends an angle at the center of a circle and then also at the circumference. So it means that our N here is going to be half of M, because that is what that theorem says. So our N is just going to be 110 divided by 2. So I don't even need to cancel. I just do divided by 2. And that is 55 degrees. And when we go and look through our answers, the correct option is B. Or the correct answer is option B. Alright. Let's move on to the next question. So the next question is question 43 of the same paper, WASSCE 2019. And this one, they didn't tell us anything. They just said find the value of Y in the diagram above. There are so many things we can think about here. let's note that they didn't give us the center of the circle. So we don't assume that this is the center of the circle. Even from the way the diagram looks, it doesn't already look like the center. So don't just go and say this is also 35 because that is what we said earlier. No. In the one we said earlier, they told us that O is the center of the circle. We could see. But here, they didn't tell us anything. So we don't assume that this is a diameter, this is also a diameter. No. We just see what we can do. One thing that is obvious is that this is a triangle. And we know the sum of interior angles of a triangle. In that case, then taking triangle MQR, I intentionally put my own Q here. The sum of interior angles should be 180 degrees. And you can see here, there is 90 degrees. So we can find here 180 minus 35 plus, which already is 125. So 55. It means that this angle here is 55. But then when we go on to the second theorem also, angles subtended by recording the same segments are the same. Then we can choose MN. We can just use a pencil to connect M and N as a chord. And when we connect, you see that this chord subtends this angle at R, and the same chord subtends the angle at P. And from that theorem, it means that the Y and this are equal. So based on that, we can just conclude that our Y is 55 degrees from the possible answers, which is option C. Up next are 4 questions I would like you to solve on your own just to get more understanding of the concept, since this topic, just as any other mathematics topic, requires a lot of practice. Pause the video, work it out, and share your answers with me in the comment box. Thank you for making time with me. Alright, welcome back. I hope these questions have deepened your understanding of circle theorems. Yeah. It's all about practice. You have to keep practicing every now and then so that you get to understand the theorems the more, because the whole topic is around the theorems. So your inability to remember and apply the theorems will affect the ability to answer the questions. So I encourage you to solve these questions over and over, go through them, look for your own questions and solve. Don't forget to solve the questions after the lesson, because they are even objective questions. So you need to solve to see whether you can get your answers from among the possible alternatives given. And you should apply the theorems. Don't get any answer without understanding how you got the answer. If that happens, means that your answer might be wrong. Alright, so on that note, I want to thank you for making time with me in my study room today. I hope to see you next time while we talk about another topic. Thank you. Don't forget to subscribe to this channel for more videos. and I hope to see you again. Bye bye.